A questo punto inizia la trasmissione. Tutti i partecipanti sono in grado solo di ascoltare.
Good morning, everybody. I'm Simone Maggiore from RSC, coordinator of the EU-MERCI project, and I welcome you with all the other partners of EU-MERCI to this second webinar, Webinar B, which will talk about the energy efficiency implementation in industry. So, we'll show a brief introduction about EU-MERCI project, and will present some of the results which we are currently obtaining during our activities, in particular related to the good practice, which will be the final output of the EU-MERCI project. My colleague will go more in details about the good practices and show how our approach to the good practice. We'll present also some results about multi-sectoral analysis, because we have analyzed several sectors. Here we present the result about some of them, so you can have an idea of our current status of activities. And when other results will be ready, we'll show you what we have obtained. So, thank you for participating. I give now the floor to Efi and Mavro from Greece, which will start the webinar. So, Efi, the floor is yours.
Hello. I welcome to the second webinar of the EU-MERCI project. I would try to be short in order to proceed to the presentation of the good practices, which is more interesting, I guess. This is some information about the project EU-MERCI that is funded by the European Union project program Horizon 2020. The objective of the EU-MERCI is to foster the growth of energy efficiency in the European Union industry by two ways. The one is through the identification and dissemination of the actual good energy efficiency practices that already occur to industries in the Union, and then to share the experience of the implementations of policies, schemes, and support mechanisms in order to be able to actually implement these energy efficiency practices. The project partners, you can see their logos. We are from different countries of the Union. And the basic idea is that the partners from countries with more experience, the enablers, as you see here, are sharing knowledge and know-how with the followers, which are the partners from the countries with less experience. And also we have the stakeholders who also share information and gather and take the expertise and the know-how in order to be able to make use of it for the growth of energy efficiency. So here we are at the webinar B. There has already been webinar A, which was more like policies and legislations and stuff. Here the aim is more focused to the transfer of the opportunities that already that occur in energy efficiency in the industries. So there has been a research done in the frame of EU-MERCI on the energy uses that are related with actual case studies. And from all these case studies, we have concluded to the definition of a series of good practices. And these are presented now here to you. Perhaps they can be duplicated or give ideas to other people that are interested in to actually implement them in their own company or industry or whatever. The sectors of this webinar is glass, pulp and paper, and cement. So the actual target after this is to improve the competitiveness, of industrial enterprises in these sectors, and this will be done by presenting techniques or methodologies which already have been applied, so that you can improve then the core business of your own industry by increasing your energy efficiency. There will be also a webinar C following. This is more targeted in each nation. It's a national targeted. It has already been one in Romania last month. And soon similar webinars will be organized in Slovenia, Bulgaria, and Greece. Again, the idea is to share the approach of good practices, but this time targeted to the nation more interested industries, sectors. Another idea of the EU-MERCI project in order to achieve the growth of energy efficiency in the Union is the capacity building action, where here the idea is to empower the national stakeholders by the organization of local workshops where good practices will be presented sector by sector and process by process. So this will get the relevant stakeholders more involved in the procedure in order to help to enhance the energy efficiency in the industries. And the validation process is actually to involve the relevant stakeholders at European Union level by providing them elements for the extension of the outputs of the project to other sectors. You can see in the slide the site of EU-MERCI. You are welcome to join us. You can join if you have best practice to share. If you are a stakeholder, you can join the stakeholder community or subscribe to the EU-MERCI newsletter in order to get the news and the results to your mail when they happen. So this is now the agenda. I am leaving the floor to Dario Di Santo from FIRE. You see more or less how the flow of the webinar will be. I hope you enjoy it and you find it fruitful. Thank you very much. Hello?
Good afternoon, everybody. It's a pleasure to be here. I'm Dario Di Santo, Managing Director of FIRE. We pronounce it in the Italian way, not FIRE. And I will try to give you some hints on why energy efficiency is important for your business and can improve the industrial competitiveness. Just 2 words about FIRE. It's one of Italian partner together with the coordinator of the EU-MERCI project. We are an association founded in 1987 that deals with the energy manager network in Italy on behalf of the Ministry of Economic Development, and that has 400 members that cover all the energy sector, from power producers to technology producers, utility, ESCOs, and large and medium end users, both in the industrial sector and in the service one. So we have quite a broad, holistic vision on the energy sector, and we translate it in our actions, such as dissemination, information, training, study on the market, on the policies, and the technologies, and so on. And we are active at the European level on various projects. One is EU-MERCI, and the others are listed here and deal with small and medium enterprise, energy performance contract, and policy evaluation. And lastly, we are members of the Energy Efficiency Financial Institution Group, that is an initiative at European level to facilitate energy efficiency financing. So, starting from the questions, what is energy efficiency and why it makes sense to invest in energy efficiency and put money in it? This is, I think, a good question to start from, because many users, many people will think about energy saving if we speak about energy efficiency. And this is more or less obvious, because of course one of the main effects you expect from an energy efficiency action is to reduce the energy consumption, and so to obtain a benefit in terms of cost reduction. And this is true, of course. So to avoid the waste of energy, to avoid energy losses, to adopt the best technologies, to improve the use of renewable energy sources, all these are part of this energy saving part of energy efficiency. But on the other hand, there are other points that are worth to consider. Because otherwise there is the risk that energy efficiency remains not really attractive, because it is not seen as a part of the core business of an industrial company, or also in other sectors. So it is quite important to start thinking about the multiple benefits that are usually linked with an energy efficiency project. That means, for example, that by implementing an energy efficiency actions, you usually have also benefits in terms of reduction of the cost of maintenance, reduction of risks related, for example, the supply of fuels or electricity, improvement in the quality of the manufactured products or in the productivity of your companies, the reduction of the GHG emissions, that of course can play an important role if you are under the emission trading scheme or anyway under the industrial emissions directive. There can be useful effects on the personnel, and so on. All these effects have a value, and some study says that this value can outnumber the value of the cost reduction. According to some authors, you can even get 2.5 times worth of money from these side effects than from the cost reduction, directly related to the energy consumption reduction. So it is very important to think about these multiple benefits of energy efficiency, and of course also to the unwanted effects. In fact, can happen that sometimes a benefit can be a loss for some interventions. Let's say many energy efficiency projects produce a reduction of the maintenance cost, but there can be some particular energy efficiency project that generates a rise in that cost. So an analysis of these profits and benefits and of these losses or unwanted effects can give you a more complete picture on the energy efficiency project. And that will allow to understand the magnitude of these risks and to adopt mitigation strategies. And also to overcome one of the issues with energy efficiency, that is the perceived riskiness related to energy efficiency. I don't quite understand energy efficiency, I don't know really energy efficiency, so I fear that these great results that are promised will not come true at the end for some reasons. In fact, usually when it comes to, you just have to assess in the right way benefits and unwanted effects, and usually what you have is that the amount of benefits overcome the amount of negative effects and adapt to the cost reduction, generating more competitiveness for the industries. Another important point is that we need to change our vision about how we deal with the manufacturing process. So, for example, taking into account this study from McKinsey & Company, we have to overcome the traditional approach to energy consumption, to say, okay, and not only energy consumption, say, okay, this is my actual energy consumption. I can adopt 1, 2, 3 technologies that will allow me to reduce our energy consumption. This, of course, is a possible approach. It will lead to an improvement of the costs related to energy, but it won't allow you to get the maximum results. So it is much better to try to think, okay, I can deal with much better technologies and with operational issues, but perhaps it's also useful to think about design losses, how I can improve the design of my manufacturing line together with a better use of resources in order to increase the productivity, to reduce the costs, and so take more advantages to my company. And this is a very important point. So what I try to let you understand is it's very important to link energy efficiency with the core business, to understand that energy efficiency is not just a cost reduction unlinked with the core business of your company, but it is something that can be quite near your core business, quite interrelated with your core business. And so to try to understand how you can mix together the quantity of raw materials, the energy use, water use, emissions, and so on, to improve the profits of your production line by reducing costs or increasing the production. This is a very important trend that leaders around the world are trying to grasp and to incorporate in their core business. So this is good, this is interesting, but does it work? This is another question that usually arises in these cases. Well, this is a figure derived from a study from the Harvard Business School, but there are other examples you can find in literature that by considering a set of companies, some of them investing in environmental, social, and governance resources, some of them not, shows that over the years, investing ESG for sure improve the financial performance of this company in the stock market. So it is not just something you do for fashion or for the environment, but it's also something that you do for your profits. And this is a very important point. And so no wonder that the market leaders are quite interested in resource efficiency, in sustainability, and in energy efficiency in particular. Here you find some figures for Apple, for example, but it is not just speaking about the largest companies in the world like Apple, Google, and so on, but also smaller companies that sometimes are less known or less under the limelight can be optimal examples of how, by considering more your resource efficiency, you can improve your company profits. Another example is Lego, since I use a lot of Lego figures in this presentation. So Lego is quite on the job in terms of attention on environmental and energy issues. So you can find here their results in terms of energy efficiency improvement over the years. Their breakdown of the emission of CO2 over their supply chain and delivery chain. And last but not least, just to say how much they are thinking about energy efficiency in all the phases of their production, they are thinking about substituting oil as the main component of their bricks with vegetable components. So they don't do it because they have to, or because there are competitors that are doing this, but because this is a way to be in line with, for example, what the Paris Agreement on climate change asks from every of us. If I want to start developing this new approach toward the use of energy and the other resources, a very good tool can be ISO 50001 energy management system. It is because by adopting this energy management system, one of the key effects is a link between the energy management functions and the other business function inside a company. This creates a lot of synergies and also allows companies to understand the link between energy and the core business. So they are not seen anymore as two separate things, but something that can go together, improving the company performance. A second point important is that the ISO 50001 requires the adoption of a monitoring system, and a monitoring system allows entrepreneurs and managers to better understand how their processes work, not only in terms of energy efficiency, but also in terms of raw materials and productivity, and so to improve them and enhance their operation. The ISO 50001 standard adoption is rising over the world, with the European countries leading, thanks to the adoption 2 years before of the international standard of the European standard EN 60001, and so this is a good sign. So, what is changing? First of all, companies develop some interest in energy efficiency when they understand that they can obtain some energy reduction, so some cost reduction. This is good. Usually, this take the companies to implement some energy audit, to buy some monitoring system, so they better understand how they can improve their use of energy and so obtain over and higher benefits by the reduction of the energy consumption. Furthermore, with ISO 50001, lean manufacturing, and this type of approach, you develop the attitudes, create synergies between the different business functions inside your companies, and start creating a behavioral change within your companies. This is very important because it integrates energy efficiency in the core business. And in some years, from the adoption of the energy management system, you can start thinking about the use of resources as a business driver, not only by improving the use of energy within your company boundaries, but also looking at the supply chain, the delivery chain, and the product, because the product can be made more efficient. You can reduce the packaging, the waste, the logistic cost, and so on. All this links with what the Paris Agreement asks from every of us. The International Energy Agency says that energy efficiency is a main pillar to try to reach the targets of the Paris Agreement. In particular, more or less half of the target will come from energy efficiency actions. And by using more efficiently their resources, starting from energy, industries will also improve their competitiveness and will ensure that we'll have a leadership in their businesses in the future years. So I think that this question, so it is better to invest in tired business that carry no return in terms of money, or to start thinking about the growing ones. And energy efficiency together with sustainability is for sure something that leads to growing profits. So perhaps it's not a great question. The answer should be quite easy, I think. How can EU-MERCI help you? Because EU-MERCI is a project that deals with good practices, in particular for the industrial sector, as Effie told you before. So it is going to create a platform with the best good practice available for each sector divided by NAICS code, and also with a breakdown for every phase of a manufacturing process. So it can give you much hints on how you can improve energy efficiency in your business. So by joining the EU-MERCI community, for example, by subscribing to our newsletter in the EU-MERCI.eu website, you can get the first-hand access to the project deliverables. You can propose a shared case studies and group practice. You can get in touch with experts in terms of group practices. You can get visibility on our dissemination tools if you cooperate with us. You can understand better the national policies that deal with energy efficiency, because the first steps of the project dealt with policies. And you will get a lot of information about the opportunity you have to improve energy efficiency in your company. So to conclude with, I think it is important to understand that EU-MERCI can be a good partner to help you implementing energy efficiency actions in your company. But it would be a good idea to think about an energy management system with the certification ISO 50001 or not. It doesn't matter. What matters is to start, change the approach to the use of energy and the other resources. And first, hoping that you won't forget all this when you come back to your desk and your office. So I hope you will enjoy this webinar, and you can get some useful information from the next presentation that will give you much more details about opportunities in the industrial sector. I thank you very much for your attention, and for everything you can write us, ask for information, or even better, join our community. Thank you very much. See you next time.
And Simone, can you hear me? Simone? We cannot hear you. Okay, can you start?
Did you hear the? So it was mute before. I guess I talked before. Okay. So
Okay.
thank you, Dario, for your interesting presentation. My microphone was mute, so I repeat again what I have just said. So yes, energy efficiency, I mean, it's not a simple subject to deal with, but here in EU-MERCI, we are trying to do our best to reach. In the most important thing, we want to produce some results which are really useful for stakeholders, and therefore we thought that the examples of good practice which are taken from the real world, from really implemented cases, can be useful for you. So now, as we also made a lot of statistical and literature analysis about the energy use in some sectors, we want to present here what we have done. So I give the floor to my colleague Anna Realini, which will present the energy uses in some sectors.
Good afternoon, everybody. This work is just a short summary of something that we have done and we are still doing. The agenda of the presentation is, first of all, we will introduce how we identified processes and how we developed a taxonomy to classify the processes we encountered in the analysis of our real cases from the real world. Then we will go more in detail in how we developed two kinds of taxonomy: the generic taxonomy that can be applied to all sectors, and the specific taxonomy that derives from a process identification. And then we will take a couple of examples from pulp and paper and glass sectors. We will show you what we did from a literature point of view, the best practices we identified, and then there will be, of course, conclusions, wrap up, and next steps. And we will also give you the names of a couple of useful documents that you can read on our website. So first of all, the first problem we faced when building our database was to understand how to classify the records we had. In order to do so, we started by learning as much as possible about the sectors we were analyzing, and to do so, we started with, of course, BREF and other general literature sources. Then we read some sector studies and we had contacts with some industry associations that supported us in understanding better how a sector worked. Then we proceeded with summarizing all that we had learned from these sources, and so preparing a technical analysis of the sector, and from the technical analysis of the sector, we prepared the taxonomy that could help us classifying all the measures that we found in our database. So taxonomy is a classification that we studied in order to have a clearer and faster representation on what the industry had really done. For each measure that we found in all the 4 enablers data set, we tried to have a classification into 3 levels. First of all, a taxonomy level 1, that is in a classification into plant section. Some measures, some projects are related directly to the process. Some others are more related to the service technologies, for example, compressed air or steam distribution system. And some others are related to alternative energy generation that can be either electrical or thermal alternative energy done, for example, with biomass or wind or other renewable sources. Then there is a level 2. That is a classification into general processor phase. The level of taxonomy level 2, the detail of taxonomy level 2 depends highly on the sector. And then we have taxonomy level 3, that is the more specific one, that is a classification into a specific phase, subphase, or technology. Since we tried to describe in the best way our measures, we decided to divide the taxonomy into 2 kinds of taxonomy. First of all, the generic taxonomy, the general classification that is under categories that can be considered universal for all sectors. So, for example, most of the plants in every sector have a compressed air system or a refrigeration system. And then sector-specific classification called specific taxonomy, that is a classification that, according to technological solutions, that are applicable only to that specific sector or to a restricted number of sectors. Let's start with the generic taxonomy development. This is just a fast example. So for example, we have, first of all, the level 1 taxonomy. And if we have a measure, for example, in which we have inverter installation on air compressors used for the compressed air system of the factory, we classify it, first of all, as service technology. Air compressors, compressed air, is a service that is shared among different sections of the factory. Then we can read level 2, some example of level 2. This is for sure compressed air systems. And then it's air compressors. or it could have been motors and drives, and we could have had variable speed drives. However, depending on the kind of measure, we can univocally classify it in level 1, level 3, level 2, and level 3 generic taxonomy, and we can always relate a specific level 3 to its level 2 and level 1 in an univoc way. So it's kind of mother-child relation. Then we had a more difficult job to do so for every sector we decided to analyze and we had in our database. These are firstly all the sectors that we have analyzed, starting with food and beverage. Then we have pulp and paper, coke and petroleum, chemical industry, non-metallic minerals split among the different kinds because they have very differentiated processes. Glass, ceramics, and cement. Then we have the metals. We divided it by iron and steel and copper and aluminum. And at the end, we grouped all the sectors that could be related to a further processing of materials that had already been processed in the other sectors, especially non-metallic minerals and metals, in the machinery sector. For this work, at the moment, in this presentation, we will speak mainly about pulp and paper and glass. Pulp and paper manufacturing process is quite linear. There is raw material preparation, that is just cutting of the wood. Then there are different processes to obtain the pulp, that is both a product of the pulp and paper process, but also raw material for paper making. And we have three processes that are chemical pulping, in which we use chemical substances to obtain the pulp, the fibers from the wood. Mechanical pulping, in which the wood is chopped and the fibers are extracted in a mechanical way. And of course, when we have recycled paper, recovered fiber pulping from recycled paper. Then there is chemical recovery, that is connected to chemical pulping, that is just the recovery of some wastes from the chemical pulping to be reused in the processes. And then from chemical and mechanical pulping, we have bleaching and refining, where the obtained pulp from a dark color is treated to obtain a white color paper, especially for high quality papers. Or the repulping, if the factory is not an integrated one, but they receive dried pulp from other factories. And then finally, there is the paper making process. That is a process that is composed mainly by only one machine that is very big and has several different sections. For example, when we developed taxonomy, of course, we had to take into account the fact that we had such a variety of processes. And so we decided, of course, level 1, we have again process, service, and alternative energy. For level 2, we tried to summarize the possible processes in some macro families, macro areas. So we have raw material preparation and storage, chemical pulping, mechanical and chemi-mechanical pulping, paper recycling, and paper making. Then, if we want, for example, to identify a measure that is in the chipping of wood, we go to chipping at level 3, raw material preparation and storage at level 2, and process technology at level 1. We did the same for glass. Glass has a wide variety of products, but the basic steps of processing are very similar to each other. At least the name is the same. Then we have some sub-processes that, of course, are different depending on the type of glass. Of course, we have batch preparation, in which all the ingredients to make glass are mixed. Then we have melting and refining that happens in a furnace, and this is a step that is only partially dependent on the type of glass that we can obtain, and it's highly dependent, especially its energy consumption, on the quantity of scrap glass that we can use and remelt, because the use of scrap glass, also called cullet, reduces really a lot the energy consumption of the furnace. Then we have the conditioning and forming, that is the phase where the different products start to take their shape. So we have different processes, whether we want to obtain tubes, bottles, flat glass for windows, or glass fibers. And then at the end we have finishing and packaging, that again is of course dependent on the kind of glass of final product, but it's mainly annealing and then some other operations. Also for glass, we have a sector-specific taxonomy development. In this case, we decided to expand melting and refining for our example. That is the most energy-intensive process in glass production. And in this case, again, if we have, for example, an intervention that is on a regenerative furnace revamping, we have level 3 that is regenerative furnace. If it's possible to know whether it's cross-fired or end-fire, we can further specify. Then we have level 2 that is melting and refining, and level 1 that is a process technology. After developing a taxonomy that was useful for our database using the same level 2, we had a development from literature. So we took the brief and Energy Star and other literature documents where good practices or best practices were described, and we tried to understand how many good practices or best practices could be identified from the literature. But we will return to this point in a later presentation today. In the end, we can say that the starting point of process analysis is, of course, technical literature, but it's very important also to interact with industrial stakeholders that can give a clearer view of what really happens in the industry. The taxonomy is very useful because it allows us to classify the measures in a database, and we have a 3-level taxonomy. And from the taxonomy, we started also a literature review of the good practices in order to compare what literature says with what we have in our database. Some useful documents you will find in the next months on our website are deliverable 3.2, that is the analysis of the integrated databases, and deliverable 4.2, that will give you a picture of efficiency projects, real efficiency projects implemented by industry in every sector and in every process. Thank you very much.
So, thank you, Anna. So it was a very interesting presentation, which we show because we want to analyze the different sectors in a quantitative way. So we want to know, we don't want to start from scratch, but we decided to start from what has already been done in literature and complement these results with the analysis of actual and real implemented projects. Therefore, combining these twofold approaches has allowed us to get a comprehensive view of the energy efficiency in the sector. And therefore, the results we will present about good practice will not only will be already be implemented, but will be also validated on the field, besides taking into account what the literature also says. So now I give the floor to Paweł from KAPE in Poland, which will present another important analysis we have performed in EU-MERCI about the energy efficiency potential, because we want to compare the good practice we have extracted, but take into account also the situation in the country in which the industry should implement the good practice. So Paweł, the floor is yours.
Thank you, Simone. So my presentation will be pretty brief, and I'll talk about energy efficiency potential in selected industry sectors. And I'll try to define some key performance indicators. Okay, so now let's start with switching slide. So a quick reminder of the presentation by FIRE. So energy efficiency potential is the possible reduction of energy consumption without lowering nor the quality nor the quantity of the end product. And there are many reasons to utilize it. One of the most important reasons are operational cost reduction, because less energy consumed means less money spent on energy bills, increase of the energy security of the country, because less energy required by the industry, increases the energy security of the country, and the increase of compatibility of the country market, because lower expenditures on energy may result in lower prices of the end product, which increase the compatibility of the market, of the country market. And preservation of the natural environment and society health increase, because less energy consumed means less fuel consumed, which further result in lowering the emissions and the influence on the environment. Okay, so to measure energy efficiency, many KPIs can be developed, but the most important and the most feasible ones are the energy intensity KPIs, which can be related to either the whole plant, the process, or the whole industry. And you can take the KPIs and compare them to BAT and BREF and other reports and documents to give you a picture on your technology in the company or in the country. Okay, so energy saving opportunities are the things that you can do to lower your energy consumption, as I said before, without lowering the quality or the quantity of your product. They can be personnel related, they can be maintenance and repairs, they can be control system related, they may relate to cross-cutting technology, they may be fuel switches, and they may be related directly to the process technology. When it comes to personnel-related energy saving opportunities, they include simple day-to-day actions, because simple day-to-day actions like switching off the lights do not provide much energy savings. But however, when we talk about the scope of a whole plant or of a whole country, the energy savings are large and promising. To ensure that the simple day-to-day practices include energy efficiency, personal training of the employees should be done. This way the energy efficiency will be recognized, known, and its potential will be utilized in a sustainable way. Personnel at all levels should be included in the energy efficiency policy. One way of increasing the energy efficiency by personnel-related opportunities is the energy management program, which is a foundation for the change for energy efficiency in a company. It is essential for utilizing the full potential of energy efficiency. The energy management program, as it was discussed before, should include as well technology modernizations as well as staff training, and the program should be a continuous process. So at the end of the first revision of the program, the results should be judged and conclusions should be taken, best practices should be revealed and utilized, and new goals should be set for the new program. The internal support for energy efficiency, so informative actions throughout the company, giving positive feedback to employees in the company for energy efficiency practices, basic practices like switching off the lights, is essential for the operation for utilizing the potential of personal-related energy saving opportunities. These opportunities are very easy to use, because they do not require to stop the operation of a plant. So the production process may go on, and it does not have to be stopped. This kind of opportunities also do not require any investments made in machinery of the company. There are a lot of other non-process specific energy saving opportunities. So the measures that you can apply to virtually any company, they are maintenance and repairs related, because seal replacement, installation improvement, and other maintenance of the equipment is essential for its operation and for ensuring that the equipment consumes the lowest amount of energy possible. Also, replacing of old equipment with new one that can be related to this kind of measure. Control system implementation is for a process is a very important measure. It has been reported that installing a process control system provides at least 5% energy efficiency improvement. Cross-cutting equipment like compressors, pumps, drives, distribution lines, lighting can also be further modified to increase the energy efficiency and to ensure that our company is eco-friendly. Fuel switches can be made from fossil fuel to renewable energy sources, as renewable energy sources are often recognized as zero-emission fuels, and waste-derived fuels can be used to further limit the fuel expenditures. When it comes to process-related energy-saving opportunities that can be identified for cement industry, we have analyzed over 34 investments made in the enabler countries. We have found that the average energy consumption of each measure was around 12%, and we could divide them to phases. So in raw material and fuel storage preparation, by investing in energy efficiency, 18% of energy consumption lowering may be expected. In clinker production and cooling phase, when we intervene in this phase, 21% energy consumption improvement can be expected, and in the phase of cement grinding storage, 15% energy efficiency increase on average. And the generic measures, so not related to any of the processes mentioned above, but the non-process specific measures on average give around 10% energy efficiency improvement. Fuel switch measures have been identified to provide on average 4% energy efficiency improvement. During the project, we have already identified 14 good practices which have the energy efficiency consumption reduction of 19%. They are, however, highly process related, so they have not been listed on the slide. And I can tell, and if you want to calculate your energy efficiency potential, you could take the specific energy consumption of the phases mentioned above. So, for example, of clinker production and cooling, and multiply it by the percentage given on the slide. And you can compare it to BAT and BREF and other reports also. When it comes to glass industry, 102 measures have been analyzed in EU-MERCI. An average energy consumption reduction was found to be 22% for the measures. The energy consumption improvement, and when you divide it into phases of glass production, was found to be around 22% on average for melting and refining phase, 29% for conditioning and forming phase, and 18% for finishing and grinding process. Finishing and packaging. I made a mistake, right? When it comes to the generic measures, the energy consumption improvement expected is also 10%. We have already identified 15 good practices, and on average, a good practice can provide a reduction of energy consumption by 35%. And your energy efficiency potential of the company can be calculated in a similar way as mentioned before. When it comes to process-related energy opportunities for pulp and paper, the largest amount of records was analyzed because it was 286. The average energy consumption improvement of the record was found to be around 21%. When we divide it into phases, it counted for 11% for raw material preparation. For mechanical pulping, it was 15%. For paper making, it was 17%. In paper making process, generic measures accounted for 24% energy efficiency improvement. The recycling part of the paper making process could also be influenced, and energy efficiency improvement of this phase could be around 17%. We have already identified 37 good practices, and on average, the good practice we have identified can lead to savings of around 28%. When it comes to the energy efficiency potential of the whole industry, I will provide you with the ICF study. There were two kinds of potential. The technical potential, in which all the energy efficiency opportunities that were technically possible were included without any economic barriers. There were two kinds of economic potential analyzed. So in the first case, payback time lower than 2 years threshold was applied, and in the second case, the payback time lower than 5 years threshold was utilized. So the number of energy saving opportunities, or so-called measures, was significantly lowered in the economic potential scenarios. When it comes to non-mineral sector, which includes glass and cement industries, you can see a projection of BAU scenario, which is the business as usual scenario, the technical scenario, and the both economic scenarios from 2011 to 2050. You can see that there is a large offset between the technical scenario and the BAU scenario, and of course the economic scenarios. When it comes to numbers, you can see that the production of the non-mineral industry is expected to decrease a bit, and the energy intensity is expected to decrease as well. So we can see that by 2030, according to the technical scenario, 19% of energy intensity reduction could be reached. And in both economic scenarios, the percentage of lowering the energy consumption is reduced to around 3%. When it comes to 2050 year, the technical energy efficiency potential was calculated to be 18%, and both economic potentials were significantly lower again, but this time they accounted for around 6 to 7% of the energy consumption. The situation is similar in the pulp and paper sector. So you can, however, this time the production is expected to increase. A large difference between technical scenario and BAU scenario is still visible on the graph. So we can see that. Technically speaking, in 2030 there is energy consumption reduction of around 19% possible. but economically speaking, only about 3 to 4% energy consumption reduction is possible in the year 2030. When we go to 2050, 17% can be done, could be done if there were no economic thresholds, and when the economic thresholds were applied, the potential reduced to 6 to 7% for the economic scenarios. So there are large differences, as I have mentioned, between the technical and economic scenarios. The reasons for this are the following. There is a large payback time of the measures, which renders them unacceptable for the energy managers. The possible solution to this is providing external to the company, so support, financial support, for example, energy efficiency subsidies and similar schemes. It was reported that in some companies there is large organizational inertia towards new changes. So this problem could be solved by implementing and sustaining an energy management policy or similar measure. And lack of awareness of the company, of the people, and of the employees could be solved by informative actions taken either by the government or by the company itself. And that's all I have to present you now. Thank you for attention. You've got my contacts here.
Okay, thank you, Pavel, for this interesting presentation. You showed how we here in EU-MERCI, we are also trying to have a look on the situation of the country, how the good practice we are extracting can have an impact on the energy efficiency situation of the country itself. Therefore, we don't want to forget that a good practice, an industry, when applies a good practice, is inserted in a certain context, which can be regional, of the city, of the country in which they live. Therefore, we don't have to forget this, and therefore this kind of analysis help us to take this into account, and will also help the validation by external experts. So now, the core of EU-MERCI, we want to present our approach to good practices. So therefore, I give the floor to Miles McCarthy, Director of Carbon Trust, which will talk about this interesting topic. So Miles, the floor is yours.
Thank you very much, Simone, and welcome everybody on the call and on this webinar. It's good to speak to everybody here from London. Just very briefly to introduce Carbon Trust, we are a UK-based organisation working now internationally, but our origins come from 2001, when we were set up by UK government to support UK business and public sector, including commercial and industrial businesses here in the UK of all sizes, to look at reducing their energy consumption, to look at reducing their carbon emissions, and also to consider opportunities for investment in renewable energy solutions. I would just like to spend a few minutes just covering the approach of EU-MERCI around opportunities, and also how we defined and extracted good practices from both data sets and also from literature in the project. So in terms of looking at opportunities for energy efficiency in industry, and in particular good practice, we clearly were looking at opportunities that could deliver energy savings, deliver efficiency over and above existing. Obviously, projects that could be work economically feasible, and this is extremely important to make sure that recommendations have the potential to be implemented, and clearly opportunities that are technically feasible and are practical and appropriate for host companies to adopt. And it's important for those host companies to find the right technologies that can unlock those energy saving opportunities. When we talk about good practice, we are talking not about activities that would be expected to be implemented across the market and are currently implemented. We are talking about the next level of advancement, so projects that are established in the market but are pushing sectors forwards and would be defined as demonstration of good practice. Beyond those, there are innovations and demonstration projects which projects have looked at and some leading companies do adopt. Again, we're not going that far. We're not looking at new novel solutions. So we're looking at that middle ground between the sort of the base level of energy efficiency that should be expected across industry and the top end, which is the innovation and new solutions coming in. And what we're trying to do is identify and communicate that middle ground of where companies should be heading towards to deliver good practice. In terms of the data sources we've used in our analysis and in the project, on the left here you can see 4 enabler organizations. These are organizations that have got significant data sets of implemented opportunities within selected countries here. Looking down the list, Carbon Trust UK, Austrian Energy Efficiency clearly in Austria, Kappa in Poland, and RSC in Italy. The sources of data that we've used for opportunities come from each of these organizations and have differences and come from different backgrounds in terms of timeline and also sources of data and purpose of data. So in the process of extracting that data, there has been a lot of work done to ensure that we can harmonize the data and use it in a single EU-MERCI database. Just quickly going down the 4 data sets, Carbon Trust has what we call our closeout database, which is an extensive database of nearly 200,000 recommendations from 2002 to 2010, and these are recommendations that have been identified and implemented within UK businesses through a government-funded advice program supporting organisations to both identify and implement those measures. Austrian Energy Agency has provided data from 2 sources, KPC, Communal Credit Public Consultant, which is a subsidised funding program 2011 to 2013, and there's about 3,000 measures in there. They also have their Climactive database, which is a database of audits completed between 2008 and 2014. Kappa and RSC have white certificate mechanisms from audits and from tradable energy efficiency certificates over periods from 2005 in Italy and 2012-2016 from Poland. So you can see that there's a number of different data sets, different scale of opportunity ranges, and as I mentioned earlier, that harmonization process has needed to ensure that we can create a common taxonomy and common data set that we can combine to form that single database, which then allows us to carry out the appropriate analysis. So we then took the approach of prioritization of sectors, and here you can see a list of 8 sectors that we have prioritized based on a number of factors that you can see along the top of this chart. So each column is a measure that we've used to evaluate things like the size of the sector in terms of carbon emissions in Europe, in terms of the potential energy saving opportunities from our experience, and also measures such as the scale of energy cost as a ratio of total value added in that sector. So there's a number of different measures we've used to evaluate each of the sectors, and we've created a scoring approach that gives us some form of ranking of those sectors in terms of importance and potential when we're looking at energy efficiency, and that has allowed us then to focus down on those sectors. And you can see at the bottom of that chart, we have from our data set and from those 4 source countries, nearly 3,000 implemented energy efficiency opportunities from those 8 sectors that we are able then to utilize in our analysis and conclusions. In terms of then looking at that data set of 3,000 recommendations, we have taken a number of activities. We've carried out a number of activities to really work on that data and also to fine-tune the findings. And you can see here, which I'll go into in a little bit more detail, the 3 steps: KPI analysis, statistical analysis of the data, and also then some engineering application to the findings and conclusions to be drawn to achieve our set of good practice guidelines for each of those 8 sectors. So in terms of KPIs, from the data we have defined and then evaluated a set of KPIs for each type of opportunity within the 8 sectors. And you can see here that those KPIs, which are defined in more detail and in the literature of the project, which can be sourced, a number of factors that we believe are important to evaluate for each measure, and also the data would allow us to evaluate across the 4 source countries and the 5 source data sets. So you can see there a number of factors that have been used, a number of KPIs from technical KPI, looking at the scale of efficiency and energy savings achievable from that measure, to economic, looking at the financial performance of those measures, as well as environmental impacts, scale of carbon savings. And then the statistical analysis, which is currently being carried out, then takes those KPIs and takes those 3,000 recommendations across those 8 sectors and looks to evaluate each recommendation against a sectorial average, median, mean performance of different KPIs. And basically what that then does is allow us to evaluate each recommendation in terms of relevance and impact. And then we can then, once we've done that prioritization across each of the recommendations, then evaluate each process step in the sectors and also each recommendation type to look where there are some higher performing commonalities within that data set, which drags out the stronger themes of opportunity within each of the stages and within each of the sectors that we have selected. And the third step is our engineering expertise, and this is really ensuring that what the data is telling us is also backed up by our technical understanding and also reported literature reports on these sectors and key findings that have been achieved. So there's been a lot of work done looking at published literature and good practice within these key sectors that we're looking at, and cross-connecting that to the data and ensuring that what we are seeing is appropriate and correct for these 8 sectors. So an outcome, therefore, that we can create from this work, this extensive work analyzing these data sets, prioritizing them from the KPIs, and then evaluating those outcomes, is a set of a library of opportunities by sector. Here you can see an example, which is the pulp and paper process, which then through the different stages of the pulp and paper processes, common steps, we can identify those prioritized good practice opportunities that come out of each of the, which relate to each of the steps that come out of all of this analysis. And that will then allow us to publish a set of recommendations for each of these steps for each of the selected 8 industries. And that was all I was going to cover in my brief part of this presentation. Thanks again for everyone's time. Here are my contact details. Please feel free to drop me an email or a line just if you have any questions on what I've covered, but also look forward to a number of you participating in the project as we progress through this year. Thank you very much, and Simone, over to you as chair. Thank you.
Okay, so thank you, Miles, for your presentation. So now I think you clearly showed how we extracted a good practice, in particular how we started from the analysis of really implemented energy efficiency project which were present in the national database of Italy, UK, Poland, and Austria, to extract the most interesting one and complement with both with the literature analysis, which is currently being performed, and with the validation, which will be performed by external experts. So now we want to present, last part of this webinar, some examples of good practice. So you can currently touch, you can see what is our work and how we want to present and express our results based on our methodology in some sectors. So there are some examples with the 3 different sectors, just to give you a hint on what we are currently doing. So I give you the floor to Anna, which will present some examples in 2 different sectors.
Good afternoon again. This presentation will be done half by me, half by Pavel Znitko from CAPE. I will present mainly paper and glass sectors examples, and Pavel will present the cement sector examples. The agenda is, first of all, we will give a brief definition of best practice and good practice. Then there will be the examples from the 3 different sectors, and then conclusions and wrap up. First of all, we have started our work by defining what is the best practice. Best practice is a method or technique that has been generally accepted as superior to any alternatives because it produces results that are superior to those achieved by other means, or because it has become a standard way of doing things. The questions that we put to ourselves were: sometimes we find practices in literature that are defined as best practice, but are they technically feasible? Are they economical to implement? So at the end, are they applicable in the real world? Then we arrived to our concept of good practice. For us, for EU-MERCI projects, good practice is a technique or methodology that, through experience and research, has been proven to reliably lead to desired results with the minimum use of resources. So it has 3 main characteristics. It's efficient, it's economically feasible, and it's technically feasible. The added value of EU-MERCI good practices is that they are taken from the real world, and they will be validated in Work Package 5 that will start in next month. Let's start with the glass sector. From literature, as we said before, we had done a literature review of all the best practices that have been identified in different documents. We have found around 60 good practices, of which 6 are on cross-cutting technologies, mainly the ones that we had called service technologies, and 54 are more sector-specific. More specifically, we have 6 best practices identified in batch preparation, 35 in melting and refining, 6 in conditioning and forming, and 7 in finishing and packaging. At the end, we will present on our website, on our portal, where we will have, of course, the schematic of the process as shown before, with the list of good practices, best practices actually from literature. And next to these best practices from literature, we will have a symbol of EU-MERCI. If some practice in EU-MERCI database is the same, is reported and it's similar to the best practice that is found in literature, and also the symbol with a star if it's a good practice identified in EU-MERCI dataset. Of course, if we find some practice that has very good performances but is not reported in the best practices from literature, we will add it to the schematic. So for the glass sector, we decided to present what we decided to call a cluster. For some sectors, we have some prominent processes that are very energy consuming. And so we have discovered that in our data set, the records that are related to this processes are a very high number. In particular, for example, in the glass sector, out of 148 records, we have about half that are related to melting and refining, and more specifically to the furnace. So we decided to form a furnace cluster in which we analyze the different types of furnaces and the good practices related to these different types of furnaces. We have decided to structure this cluster in the following way. We have a general description of the technology of the process. We have identified the different types of interventions with their own description that can be replacement, revamping, or introduction of oxy-fuel combustion, for example, in this case. We evaluate the applicability to the different types of furnaces. We report statistics about energy savings, saved CO2 emissions, payback time, and other economic indexes. And above all, we report all the statistics about the KPIs that we have found for this cluster of good practices. And then, of course, some comments. So, for example, we have a number of considered interventions. This is related only to RSC dataset, but it will be extended to the other datasets from the other enablers in the next weeks. For example, we have 23 revampings, 13 replacement, and 5 introduction of oxy-fuel or replacement of the furnace with one that has oxy-fuel. Replacement and oxy-fuel are very easy to understand. Replacement, I take a furnace, I change it. It's a very long and complex process. It takes a lot of effort, a lot of work, but it's just one action. Oxy-fuel, again, it's from using air to burn substances. I use oxygen, very easy. Revamping is more complex. Revamping is usually performed when the furnace is in the middle of around 2/3 of its life, and it's used because the replacement of a furnace is very expensive. Revamping is less expensive and allows to extend quite a lot the life of the furnace. We have identified in our dataset 8 different actions that can be performed on the furnace when it's revamped, and especially we have identified that our records have 3 to 8 actions, so at least 3 of these are performed in different combinations and up to 8. Of course, the first is replacement of recuperative chambers. Then there is the surface insulation with more performing refractory material, combustion optimization that can be done in different ways, optimization of furnace regulation system, so the control system of the furnace, for example, by measuring the quantity of the different substances in the flue gas and to better calibrate the fuel quantity and the air intake. The re-layout of flue gas tubes to improve heat exchange, the re-layout of furnace geometry, again, to improve heat exchange, the replacement of the burners in order to use low NOx burners, and the sealings of expansion joints in order to reduce heat loss towards the external. These actions might be applicable to all types of furnace or just to some of them. Most of the actions are applicable to all types. Of course, the replacement of recuperative chambers are applicable only to recuperative furnaces, and there are different kinds of burners or regulation systems that might be applicable to different types of furnaces. The replacement, of course, can be applied to all types of furnace. The oxy-fuel is not recuperative because oxygen is usually not preheated, and more important, since oxygen requires a huge amount of energy to be produced and to be transported, oxygen shall be available near the plant or in proximity of it, or shall be produced inside the plant. Statistics, we have reported in this slide only the average, but in the full description that you will find in our documentation, the whole statistics will be reported. The baseline is usually around 10,000 tons of oil equivalent per year. The average energy savings obtained by these measures are 2,200 tons of oil equivalent per year. The energy consumption improvement is around 25%, the average one, of course, of the database. The capex that is spent for save 1 ton of CO2 is 1,700 euros for each ton of CO2, and the payback time is around 6 years. Then there are the comments. What we say the comments here, we have just some examples. Of course, they will be longer in the documents. First consideration is that melting is a very energy-intensive process, so baseline and savings are very high, especially if savings are obtained by such an important intervention like a replacement or revamping. Energy consumption improvement is high because most of the furnaces that are ongoing revamping or replacement are old. They are maybe 6, 8 years old out of a life of 12, 14, 15 years. And payback time is very high if we consider the average payback time for industry that shall be 3 years. But let's consider that 6 years is less than half of the life of a good furnace. So it's quite good payback time. Then we go to the paper sector. For the paper sector, we have followed a different approach. Instead of using a cluster, we decided to consider the single processes. From literature, we have found that there are around 54 best practices, of which 6 are cross-cutting technologies, service technology, and 48 are related to the main processes. We can see that the most affected processes are chemical pulping, mechanical pulping, and paper making. A little bit in raw material preparation, the others are less affected by the best practices, of course, because they are also simpler processes. Again, as already said for the glass, we have these symbols that we will use in our portal to identify whether a best practice has been applied also in EU-MERCI dataset, with a star if it has been identified also as a good practice in EU-MERCI dataset. And then we go to the real world. Real world, in this case, we have decided to present 3 cases that are the example of different kinds of cases we can have in our dataset. First measure is on the roll coating machine revamping through burners optimization, roll coating, so at the end of the paper making. The measure is combined because we have replacement of burners and inverters. The sub-process is paper making, roll coating, and the intervention is described by the general description, but basically is a new hot air system with a different distribution of the burners in the tunnel that can give a more homogeneous heating, so a temperature distribution that is more homogeneous and less fuel consumption. Of course, related to the hot air system, there is the air recirculation system, and the second action in this measure is the reduction of load on the fans thanks to the new air recirculation system, but also to the use of inverters on the recirculation air fans. In this case, we had just one measure, so we don't have average, we have the direct values. The baseline is around 2,000 tons of oil equivalent with savings around 1,000, so an energy consumption improvement that is more than 50%. The capex is quite high over the saved CO2, is around 3,000 euros, and the payback time is 10.5 years. This measure has been found only once in our dataset, and it has been identified as a technical good practice. Savings and consumption improvements are very high and contribute positively to the objective of the European Union in terms of energy efficiency. The payback time is quite high, but one of the outcomes that we hope to have from our project is also to give some suggestion to the policymakers on how to improve their policies. So maybe they can improve the incentives they are giving to very good practices that at the moment are too expensive to be implemented. A second consideration to be taken into account is that we compute payback time without considering the value of the incentives received, either with white certificates or other schemes. So In this case, probably it was reduced by the fact that some incentives were given to the company. Second example is going back in the process is in the mechanical pulping. It's the installation of some teeths in the defibration plate of the mechanical pulper that avoid the regrinding phenomenon, that is the permanence of the pulp on the surface of the grinder, that increases the energy needed because there is less space for fresh wood to go to the pulper and to be grinded. So this new plate allows the better distribution of the pulp on the sides of the grinder, so reducing this regrinding effect. Again, statistics. This was a single measure, unique in the data set, so we only have one value for each indicator. Baseline is a little bit less than 6,000 ton of oil equivalent per year. Savings are around 1,000. The energy consumption improvement is around 20%. Here we have a good example of measure that is not so expensive because we have very low capex for each saved CO2 and also very low payback time. Some comments is that this measure is unique in the data set. It has considered a good practice, both from a technical point of view, because it's very easy to implement, and also because it has a very low investment cost and a low payback time over the quantity of savings and the quantity of saved CO2 in the environment. Then we have a third example. The third example is something that stays in the middle. It's again a single measure on the drying section, and it's a revamping on the drying section that is not invasive, but it's easier than other improvements to be put in place. And it's very easy also to understand. They just improve the cleaning of the paper transport system in order to improve the heat exchange between the paper and the heat exchangers, and the steam mainly, and so improving, reducing the consumption of natural gas that needs to be burnt to obtain the steam used for drying. This system of double cleaning is very easy to install on the sides of the machine, as you can see. And here we had more than one intervention. We had at least 3 times with exactly the same intervention. So here we have again the average. We can see that the baseline is very high because drying is a very energy intensive part of the paper making machine. Energy savings are high, but if we consider the relative energy consumption improvement is just 6.5%. It's not bad, but it's not the most perfect one. But the capex is not very high over the CO2 saved, and also the payback time is considered acceptable for most industry investments, and so this is a measure that could be put in place also if the incentives were lower or there were no incentives, like in some cases that we found. For pulp and paper and glass, this is it. I think that Pavel can take the microphone and speak about the cement sector. Thank you very much.
Okay, Pavel speaking again from CAPE. When it comes to the cement sector, as similar, just a second, I need to follow up. When it comes to the cement sector, a similar literature analysis taking into account BAT, BREF, Energy Star, and other documents is currently undergoing. A similar process schematic has been created, and we have found in the literature 30 sector-specific good practices and 6 good practices that can be related to cross-cutting technologies. In the raw material preparation part of the process, 6 best practices in literature have been defined. In the fuel preparation part, only 4 best practices. In clinker production and cooling, 14 best practices. And in cement grinding storage, 6 best practices from the literature. A similar list of best practices for the cement industry in each phase is being created, and reference, not reference, but recurrence in real world of the good best practices mentioned in the literature is marked with the EU-MERCI triangle, given a good best practice or a good practice named to the practices that appear in the real world. Now let's talk about some examples. So the first example to talk about is a very generic one, which is kiln heat recovery. This is a single measure, and it influences the process of kiln sintering of materials. In the situation before the intervention, the kiln using fossil fuels had no heat recovery system. A heat recovery heat exchanger was installed to the flue gas duct, and the heat was recovered. The heat may be recovered for preheating combustion air, which is pretty obvious, or it can be used as a heat source for other processes like brick drying process. You've got the average statistics here. So baseline around 105 TOE, around 203.5 TOE per year energy savings. Energy consumption improvement, it was found to be average around 21, 277.5 euro per ton of CO2 emission avoided, and a payback time of, on average, 2.65 years. So the payback time is pretty acceptable. About this measure, we can say that this measure is easily simple, and it's very easily replicable to all the factories, or to all the factories of the cement industry, or to even factories out of the industry sector. So basically, any industry which has a kiln can install a kiln heat recovery and can use waste heat for different processes. The KPIs of the good practice of the kiln heat recovery are hard to define uniquely. I mean, hard to define on average, so that because the baselines often and energy savings often depend on the place of application of the recovered waste heat. So sometimes energy savings in different parts of the factory are reported as a result of the heat recovery. The measures, the heat recovery measures from kilns have very acceptable payback times, and the capex is not so high. So the capex related KPIs are also not high. The measure reoccurs at least 3 times in the whole data set. The next example I've got today is sand milling plant optimization. So sand and other additives that are added to the cement mixed before it enters the kilns have to be mixed and grinded and ground. The additives and in general, the grinding process is, in general, the moisture amount of sand influences directly the amount of thermal energy that is required later in the process to dry the sand. So changing from the wet milling to dry milling of sand should result in large energy saving in the whole plant. And you can see that in the slide. So the baseline is not so large because this is only the grinding process is considered. The energy savings, however, refer to the drying process, and that they are pretty high, and the energy consumption improvement is also pretty noticeable. However, capex per each CO2 ton saved is pretty large, but the payback time still seems acceptable. And the energy measure with the sun milling plant optimization is energy efficiency measure, which largely saves large amounts of energy. It reoccurs at least 2 times in the dataset. This kind of measure is simple, easy, replicable, and has a significant influence on the total of the sub-process, and it has got acceptable payback time. Next measure, which I want to show you, is a very simple one, which is sand, and is still connected with sand, which is the measure is sand stockpile dewatering system. This is a single measure in the process part called raw material storage. Basically, sand stockpile dewatering system was installed, and the system reduced the moisture of the sand, thus having a direct influence on the energy requirement of the process. The baseline of the measure is large because it refers to the whole process of sand drying. The energy savings seem pretty low because and so does the energy consumption improvement. However, the capex per each CO2 emission ton avoided is pretty low, and the payback time is low because it is a very simple measure and it's not highly process related, so it can be implemented to other storage of raw material parts of other plants. The measure is unique in the dataset, so the statistics shown are not average, they are unique. The baseline, as I said before, it was related most probably to the drying process, so the energy consumption improvement doesn't seem so high. However, as I said before, the measure is simple, easily applicable, and it saves some energy. And this measure is a good example of how even the sand storage part of the process can be further improved. The next and last good practice I want to talk about today is raw material preparation fuel replacement, which will be put in the renewable energy sources cluster. This was a single measure. The type of measure is single, and the part of the process which it influences is raw material drying. General description of the measure is that there was a fuel switch made, usually from fossil natural gas to biomass. Most probably, these were wood chips, and the energy produced was supplied to the raw material drying process. The baseline of the measure is on average 15,245 TOE. The energy savings are large too. However, when we refer them to the baseline, they account only for 7% of the baseline. The capex for each ton of avoided CO2 emission is very low, and the payback time is very low because the biomass can be sometimes considered a waste material, which is free, or which can be acquired with low cost. Also, biomass is often considered a zero emission fuel. That's why the capex per each CO2 emission saved is also low, because there was large saving in CO2 emission, basically. Usually, when we talk about measures which include fuel switches to renewable energy sources, they have small or no prime energy savings, because basically we substitute the fuel to the process. So the process itself remains unchanged and its energy consumption remains unchanged. But they are still good practices because, as I said before, biomass and other biofuels are considered zero-emission fuels, and they comply with EU objectives. So it has been decided that the renewable energy sources will be put in a separate cluster, not to avoid them being handicapped with having zero primary energy saving KPI. This kind of measures have relatively low investment costs, and their payback is very low. As you have seen, it was around half a year. They are largely replicable to all the other plants using furnaces, kilns, and we have found at least 3 similar records in our data set. So now, thank you for your attention. I think Anna can talk about the conclusions of our analysis.
Thank you very much, Pavel. I think we can keep this presentation, no need to change it. Okay, as we have said many times, good practice can be defined in different ways. So we use both KPIs, statistical analysis, and technical expertise. We decided to do so because using only KPIs leads to choosing common practices and not necessarily the best one or the good one that we can find. As already said, for some sector, for example glass, but also cement, there are some processes that are more energy intensive than the others of the sector. In this case, in both cases, the furnaces. So we decided to collect them in clusters. Some practices that are good both in terms of energy and environmental KPIs, as already shown, need higher incentives because they have very high investment costs and they take a lot of time to pay back the investment. And at the end, we decided to treat good practices related to renewable energy sources generation in a separate cluster because otherwise we risk to lose some information about how good they are because they show no savings because there is maybe a fuel replacement from oil to biomass or so. Next slide, please, Pavel. All the information contained in this presentation will be available on some of the documents that you will find in the next months on our website, especially on deliverable 4.2, of which we have already talked about, and in the deliverable 4.3 that will be fully dedicated to the best practices and good practices. And in the future, there will be a new MERCI portal where you will see our data set, the good practices, the best practices with a full description and all the process data that are needed to fully understand how they work. Thank you very much for your attention, and our contacts are in the next slide. Thank you.
Okay. So for any questions, thank you, Anna, thank you, Pavel, for your presentation. Now you could really see what is the work we are doing, how we extract a good practice, how we present, what we want to show you, and how we want to make the results of EU-MERCI available to you. So I think now we have some time for the questions. So I can, don't know, Valentina, can leave the floor to questions.
Yes, Simone, I send you the questions on the chat, but no question has arrived until now. There are no questions. Can you hear me?
Yes.
Okay.
Okay. Okay. So if you want to know more information, I mean, you can ask us. I mean, we are all almost all EU-MERCI partner here, or if there isn't anything you want to ask, maybe you have all our contacts. I mean, or you can contact directly the speakers, or you can send email to each of us, and we'll be more than happy to answer to all your questions. If you need any more material, if you want to contribute to EU-MERCI, if you want especially to validate, to be part of a EU-MERCI community, to validate the good practices. This is the current, the strong point of EU-MERCI, because these good practices will be evaluated and validated by real stakeholders. And therefore, if you want to participate in this evaluation, just send an email to me or to Dario Di Santo, and we'll be more than happy to include you in this process. Or if you want to suggest some other good practices you want to share, you want to show at the European level in different countries, this can be a good way. Does any of the other speakers want to add anything? Okay, so if there are no questions, thank you all for participating. I hope you found this webinar interesting. And for any question, please don't hesitate to ask and to contact. I think the presentation will be made available on the EU-MERCI website, right?
Yes, of course, we will put all the presentation on the website.
Okay. And after that, there will be an evaluation questionnaire. So if you can express your opinion about this webinar, the most interesting topics you'd like to see more details, just complete the questionnaire. Then we'll be more than happy to have your opinion about what we are doing. Your opinion is important to us to improve our actions. So thank you again for participating, and we keep in touch. We'll keep you updated. Bye bye. Have a good weekend.